The morning sun rises over our modern cities, its golden rays illuminating glass towers, bustling highways, and countless human lives beginning another ordinary day. We wake to our smartphones, check our satellites, and trust that the same gentle star that warmed our ancestors will continue to nurture our technological civilization. But what if that trust is misplaced? What if our sun, the very source of life itself, harbors the power to erase everything we have built in a single catastrophic moment? Deep in the archives of ice cores and tree rings, scientists have discovered evidence of something terrifying: solar superflares, eruptions of energy so vast they dwarf anything in recorded history. Events powerful enough to strip away our atmosphere, fry our electronics, and plunge our world back into darkness. The question is not whether such events have happened before. The question is whether they have already reset human civilization, wiping away advanced societies that once thrived beneath the same deceptive sky. Consider this: every major ancient culture speaks of a great catastrophe, a time when fire fell from the heavens and the world burned. The Norse called it Ragnarok, when the sun would be devoured and the earth consumed by flames. Hindu texts describe the Kali Yuga, an age ending in cosmic fire. The Maya prophesied cycles of destruction and renewal, each world destroyed by celestial forces beyond human control. Even the Bible speaks of judgment by fire, when the heavens themselves will pass away with a roar. For centuries, we dismissed these stories as mythology, the fearful imaginings of primitive peoples who did not understand the natural world. But modern science is beginning to whisper a different truth. These myths may not be fantasies at all. They may be memories, collective recollections of real events so traumatic they burn themselves into the human psyche and survive through oral tradition across millennia. The evidence begins in the most unlikely place: the pristine ice of Antarctica and Greenland, where every snowfall for hundreds of thousands of years has been preserved in crystalline layers. When scientists drill deep into these frozen archives and analyze the trapped air bubbles, they find spikes of isotopes that tell a story of violence. Beryllium-10 and chlorine-36, radioactive signatures that appear only when Earth is bombarded by cosmic radiation far more intense than anything we experience today. The most dramatic of these spikes dates to approximately 12,800 years ago, at the end of the last ice age. The isotope levels suggest that our planet was struck by a burst of cosmic rays thousands of times more powerful than any solar event in recorded history. The timing coincides with one of the most mysterious periods in human prehistory. When the climate suddenly shifted, megafauna went extinct across multiple continents, and archaeological evidence suggests that human populations collapsed and migrated en masse. But ice cores are not the only witnesses to this ancient catastrophe. Tree rings from bristlecone pines, some of the oldest living organisms on Earth, show cellular damage consistent with intense radiation exposure during the same period. Carbon-14 levels in the atmosphere spiked to levels that would have been lethal to many forms of life. Even the rocks themselves bear scars. Fulgurites, glass formations created by lightning, appear in unusual abundance in geological layers dating to this epoch, as though the very air was electrified beyond normal measure. What could have caused such devastation? For decades, scientists focused on terrestrial explanations: volcanic eruptions, asteroid impacts, sudden climate shifts. But the global nature of the evidence, the simultaneous appearance of radiation signatures across multiple continents, points to something far more ominous: a solar event of unimaginable magnitude. Our sun is not the stable, predictable star we imagine it to be. Beneath its serene appearance lies a churning dynamo of magnetic fields and plasma flows that occasionally erupts in spectacular displays of violence. Solar flares, coronal mass ejections, and magnetic storms that can disrupt satellites and power grids even today. But these modern events are mere whispers compared to what our star is truly capable of. Astronomers studying other stars similar to our Sun have observed superflares, eruptions that release energy equivalent to billions of hydrogen bombs exploding every second for hours or days. These events are rare, occurring perhaps once every few thousand years, but when they happen, they transform their host stars into temporary beacons visible across interstellar distances. The radiation and charged particles they release travel outward at nearly the speed of light, sterilizing any planets unlucky enough to be in their path. For years, scientists believed our Sun was too old and stable to produce such extreme events. Its magnetic field seemed too weak, its rotation too slow. But recent discoveries have shattered that comforting assumption. Analysis of solar-type stars reveals that superflares are not only possible, but inevitable over cosmic timescales. Even more disturbing, evidence suggests that our own Sun may have unleashed such fury in the recent past. The Carrington event of 1859 offers a glimpse of what solar violence can accomplish even in its milder forms. When a massive coronal mass ejection struck Earth, telegraph systems around the world failed catastrophically. Operators received electric shocks, telegraph paper caught fire, and some lines continued functioning even after being disconnected from their power sources, drawing energy directly from the induced currents in the atmosphere. Aurora displays were visible as far south as the Caribbean, and the night sky glowed so brightly that people could read newspapers by the light. That event, the most powerful geomagnetic storm in recorded history, was caused by a solar flare that astronomers now classify as relatively moderate. Imagine if our Sun had released not 10 times more energy, but 1,000 times more. 1,000,000 times more. The Carrington event would seem like a gentle breeze compared to the hurricane of radiation that would follow. Modern computer models of extreme solar events paint a terrifying picture. A true superflare would begin with a brilliant flash of X-rays and gamma radiation, invisible to the naked eye but lethal to any living thing exposed to the open sky. Within minutes, the radiation would strip away the ozone layer, leaving Earth's surface defenseless against ultraviolet bombardment. The atmosphere itself would begin to glow like a neon sign as charged particles cascaded through the upper layers. Hours later, the main event would arrive. A wall of magnetized plasma traveling at thousands of kilometers per second would slam into Earth's magnetic field with the force of countless nuclear weapons. The protective magnetosphere that shields us from cosmic radiation would collapse and reform in chaotic patterns, allowing deadly particles to rain down on the surface. Any electronic device not properly shielded would be instantly destroyed by electromagnetic pulses millions of times stronger than anything produced by human technology. But the electromagnetic effects would be only the beginning. The superflare's radiation would ionize the atmosphere, creating electrical phenomena beyond imagination. Lightning storms of unprecedented intensity would rage across the planet. The very air would become conductive, turning the sky into a vast electrical circuit. Ground currents induced by the magnetic chaos would flow through the Earth itself, melting metal, starting fires, and creating fulgurites wherever the energy found release. The climate effects would be equally catastrophic. The sudden influx of energy would heat the upper atmosphere to temperatures exceeding those found in blast furnaces. Nitrogen and oxygen molecules would break apart and recombine into exotic compounds, creating a toxic fog that would blanket the planet for months or years. The ozone depletion would persist long after the initial event, allowing sterilizing ultraviolet radiation to penetrate to the surface and destroy plant life across entire continents. In such a world, human civilization as we know it would simply cease to exist. Not gradually, not through war or disease or slow decline, but instantly. Every satellite would be destroyed, every power grid would fail, every electronic device would become a lifeless lump of metal and silicon. Cities would burn as electrical systems overloaded and gas lines ruptured. Transportation networks would collapse as vehicles with electronic components stopped functioning. Communication would be impossible except for those few who still remembered how to build crystal radios and Morse code transmitters. The survivors, if any, would find themselves thrust back into a pre-technological age without warning or preparation. No books would explain how to forge steel or grow crops without modern fertilizers. No teachers would remember the accumulated knowledge of centuries. The infrastructure that supports billions of people would crumble, leaving small bands of humans to rediscover fire, agriculture, and basic survival in a world stripped of its protective atmospheric layers. Yet even in this nightmare scenario, some knowledge might survive, not in books or computers, which would be destroyed, but in stone, in carefully crafted monuments designed to preserve information across cosmic timescales, in astronomical alignments that encode the positions of stars and the cycles of celestial events, in mathematical ratios carved into indestructible materials, waiting for future civilizations to decode their meaning. Could such preservation have already occurred? Could the mysterious monuments that dot our planet, structures whose precision and sophistication seem to exceed the capabilities of their supposed builders, be messages from a previous civilization? One that faced the same stellar fury we may yet encounter? The timing suggests it might be possible. The great building phase of megalithic monuments around the world, from Göbekli Tepe to Stonehenge to the temples of Malta, began shortly after the mysterious catastrophe of 12,800 years ago. As though the survivors of some great disaster had emerged from hiding and begun the urgent work of rebuilding, not just their societies, but their knowledge, encoding what they remembered in forms that could survive the next cycle of destruction. The archaeological record whispers of sudden changes that align disturbingly well with the timeline of cosmic catastrophe. Around 12,800 years ago, something fundamental shifted in human development. The Clovis culture of North America, sophisticated hunters who had thrived for millennia, vanished almost overnight. Their distinctive spear points disappear from the geological record as abruptly as if someone had switched off a light. In their place, scattered bands of survivors developed entirely different technologies, cruder tools, and survival strategies suited to a harsher world. Across the Atlantic, similar disruptions echo through time. The advanced Ice Age cultures of Europe, who had created the stunning cave paintings of Lascaux and Altamira, suddenly abandoned their artistic traditions. The sophisticated bone tools and ivory carvings that characterized their civilization gave way to simpler implements, as though the knowledge of their creation had been lost in a single generation. Archaeological sites show evidence of rapid abandonment, with tools and artwork left as if their creators had simply walked away and never returned. Even more intriguing are the geological signatures found at these transition sites. Layers of black material, rich in carbon and exotic minerals, separate the older cultures from the newer ones. When analyzed, these dark bands contain microscopic diamonds, metallic spherules, and elevated levels of platinum and iridium, the same materials that appear when cosmic radiation interacts with Earth's atmosphere at extreme intensities. It's as though a layer of celestial ash had settled over the world, marking the boundary between one age and the next. The pattern repeats across continents with unsettling consistency. In Australia, the Aboriginal Dreamtime stories speak of a period when the sky burned and the ancestors retreated underground. Archaeological evidence shows that around the same time, human populations there experienced a severe bottleneck, with genetic diversity suggesting that only small groups survived in isolated refugees. The rock art changes dramatically at this boundary, shifting from naturalistic depictions of animals to abstract symbols and geometric patterns, as though the artists were trying to preserve something more fundamental than mere representation. In South America, the advanced Paleolithic cultures that had spread across the continent suddenly fragmented into smaller, more primitive groups. Their sophisticated stone tools give way to cruder implements, and many regions show signs of complete abandonment for centuries. When humans finally returned to these areas, they brought different technologies and cultural practices, suggesting that the original knowledge had been lost and had to be painfully rediscovered. But perhaps the most compelling evidence comes from the survivors themselves. The genetic record reveals that all modern humans outside of Africa descend from a remarkably small population that existed around 12,000 years ago. This bottleneck, known to geneticists as the late Pleistocene population crash, coincides precisely with the time frame of the suspected solar catastrophe. It's as though the entire human species had been reduced to scattered bands of refugees, struggling to rebuild from the ashes of their former world. The oral traditions of indigenous peoples worldwide preserve memories that seem to describe this very scenario. The Hopi speak of the end of the Third World, when the sky fell and fire rained from above. The Lakota tell of a time when the sun grew angry and burned the earth, forcing the people to hide in caves until the danger passed. Australian Aboriginal stories describe the rainbow serpent's fury when lightning filled the sky for days and the land itself caught fire. These are not isolated myths, but part of a global pattern of catastrophe narratives that share remarkably similar details. The sky burning, electrical phenomena beyond normal experience, the need to shelter underground, and the loss of advanced knowledge. When viewed through the lens of solar superflare theory, these stories take on an entirely different significance. They may be the last remnants of eyewitness accounts, passed down through generations of storytellers who preserved the memory of humanity's darkest hour. Modern astronomy provides additional support for this hypothesis. Observations of young, sun-like stars reveal that superflares are not only possible but expected during certain phases of stellar evolution. Stars similar to our sun in mass and composition regularly produce flares thousands of times more powerful than anything we've recorded. The frequency appears to be cyclical, tied to long-term changes in stellar magnetic fields that operate on timescales of thousands of years. Our own sun shows signs of past violence that we're only beginning to understand. The solar minimum periods when sunspot activity drops to near zero may actually precede the most dangerous flare events. Historical records show that the Maunder minimum of the 17th century, a period of reduced solar activity, was followed by increased auroral displays and unusual atmospheric phenomena. Chinese astronomers from that era described guest stars appearing near the sun, possibly witnessing solar flares so intense they were visible against the daylight sky. Tree ring data from around the world reveals additional evidence of past solar hyperactivity. Carbon-14 spikes in ancient wood samples indicate periods when cosmic radiation bombardment was far more intense than today. The most dramatic of these events cluster around specific dates that correlate with major disruptions in human civilization. The collapse of the Bronze Age around 1200 BCE, the fall of the Roman Empire, and the mysterious Dark Ages that followed all coincide with periods of unusual solar activity preserved in the dendrochronological record. Even more disturbing is the discovery that these events may be accelerating. Solar physicists studying the sun's magnetic field have detected changes that suggest we may be approaching another period of instability. The solar poles are shifting more rapidly than predicted, and the magnetic field that protects us from cosmic radiation is weakening at an alarming rate. Satellite measurements show gaps appearing in Earth's magnetosphere, temporary windows through which deadly particles can reach the surface. The implications for modern civilization are staggering. Unlike our ancestors, who lived in small, scattered communities with minimal technological dependence, we have built a world that relies entirely on electrical systems and satellite communications. A superflare event today would not just destroy our technology, it would collapse the complex supply chains that feed our cities, the medical systems that keep millions alive, and the financial networks that maintain global commerce. Consider the cascading failures that would follow even a moderate solar event. Power grids across entire continents would overload and shut down, not for hours or days, but for months or years as transformers burned out and spare parts became impossible to manufacture or transport. Without electricity, water treatment plants would fail, leaving billions without access to clean drinking water. Food distribution systems would collapse as refrigeration failed and transportation networks broke down. Hospitals would become death traps as life support systems failed and medication spoiled without proper storage. Nuclear power plants designed to shut down safely during emergencies might experience catastrophic failures if their cooling systems lost power for extended periods. The spent fuel pools that store radioactive waste at hundreds of sites worldwide could begin boiling, releasing deadly radiation into the atmosphere. But the human cost would extend far beyond the immediate technological failures. Modern urban populations have lost the survival skills that sustained our ancestors through previous catastrophes. Few people know how to purify water without modern chemicals, grow food without industrial fertilizers, or preserve meat without refrigeration. The knowledge that allowed small communities to rebuild after past disasters exists now only in books and digital files that would be destroyed in the first moments of a superflare event. Yet within this terrifying scenario lies a glimmer of hope and perhaps an explanation for the mysterious monuments that continue to puzzle archaeologists around the world. If previous civilizations faced and survived similar catastrophes, they may have developed strategies for preserving essential knowledge across cosmic timescales. The precision-cut stones of ancient temples, the astronomical alignments of megalithic circles, and the mathematical relationships encoded in pyramid architecture may not be mere artistic expression or religious symbolism. They may be libraries, information storage systems designed to survive electromagnetic pulses, atmospheric fires, and the collapse of technological civilization. Knowledge encoded not in fragile books or electronic media, but in the relationships between stone blocks, in the angles of shadows cast by carefully positioned monuments, in the acoustic properties of chambers carved from solid rock. The mathematics preserved in these structures encompasses far more than basic geometry. The golden ratio appears in monuments separated by thousands of miles and years, suggesting that whoever built them understood principles of harmony and proportion that modern science has only recently begun to appreciate. The astronomical alignments track not just the obvious cycles of sun and moon, but the subtle precession of Earth's axis over periods of 26,000 years. This is knowledge that requires centuries of careful observation to accumulate and sophisticated mathematical understanding to encode. It suggests that the builders were not primitive peoples struggling to understand their world, but survivors of an advanced civilization working desperately to preserve what they could of their ancestors' wisdom before the next catastrophe arrived. The urgency of their work becomes clear when we consider the timeline. Most of the world's great megalithic monuments were built during a relatively brief period following the last suspected superflare event. As though the survivors had emerged from their shelters, assessed the damage to their world, and immediately begun the critical task of encoding their knowledge for future generations. They could not know when the next cosmic fury would arrive, but they understood that it would come. The cycles of stellar violence are as predictable as the seasons, operating on timescales that dwarf human lifespans but remain constant across cosmic ages. Their monuments were not built to glorify kings or appease gods, but to serve as beacons of knowledge for the civilizations that would rise from the ashes of the next great burning. The evidence suggests we may be living in one of those rising civilizations now, rediscovering knowledge that was once common but was lost when the sky last caught fire. The technological explosion of the past few centuries, the sudden leap from horse-drawn carriages to space travel in less than 200 years, may not represent humanity's first encounter with advanced science. We may be climbing a ladder that others climbed before us, following pathways carved by minds that face the same stellar threat we now confront. Archaeological anomalies that have long puzzled researchers begin to make sense when viewed through this lens. The precision-machined granite boxes found in Egyptian temples, crafted to tolerances that challenge modern manufacturing capabilities. The massive stone blocks fitted together so perfectly that a knife blade cannot slip between them, found from Peru to Lebanon to Easter Island. The evidence of advanced metallurgy in ancient sites, where traces of steel and even titanium alloys appear in contexts supposedly limited to bronze and stone tools. These are not the products of primitive civilizations slowly developing their skills. They are the remnants of knowledge systems that were already ancient when the monuments we know today were built. Fragments of understanding preserved by survivors who had seen their world burn and were determined to leave instructions for those who would follow. The pattern becomes clearer when we examine the knowledge encoded in these structures. The Great Pyramid of Giza, beyond its astronomical alignments and mathematical relationships, contains information about Earth's physical properties that was not officially discovered until the modern era. The monument's base perimeter, when multiplied by specific ratios, yields the planet's circumference to remarkable accuracy. Its height encodes the distance from Earth to the Sun. Its internal passages align with stellar positions that were last visible from that latitude over 10,000 years ago. This is not the work of Bronze Age architects guessing at cosmic relationships. It represents knowledge accumulated over millennia by civilizations that had mapped the heavens with precision and understood their place within the larger cosmic dance. Knowledge that was encoded in stone when those civilizations faced extinction, preserved for the day when humanity would once again possess the tools to decode their message. The same pattern emerges at sites worldwide. Stonehenge tracks not just the obvious cycles of sun and moon, but subtle variations in Earth's orbit that repeat over periods of thousands of years. The temples of Angkor Wat in Cambodia incorporate measurements that encode the precession of the equinoxes, a celestial phenomenon that requires centuries of careful observation to detect. The Nazca lines in Peru may not be mere artwork, but a coordinate system preserving the locations of resources and safe havens for post-catastrophe survivors. Even the myths and legends that surround these places carry encoded information. The story of Atlantis, dismissed by mainstream archaeology as pure fiction, contains specific details about advanced technology, global trade networks, and sudden catastrophic destruction that align disturbingly well with what we now know about the effects of extreme solar events. Plato's account describes a civilization that had mastered metallurgy, possessed flying machines, and used crystals for power generation, all of which would be logical developments for a society facing the threat of electromagnetic catastrophe. The timing of Atlantis' destruction, according to Plato's Egyptian sources, places it at approximately 11,600 years ago, well within the window of the suspected Superflare event. The description of the disaster itself, with the earth shaking, the sky burning, and the sea boiling, reads like an eyewitness account of what we would expect from a massive coronal mass ejection striking an unprepared world. But perhaps the most intriguing aspect of these ancient accounts is their consistent emphasis on cycles. The Hindu concept of yugas describes repeating ages of rise and decline, with each cycle ending in cosmic fire followed by renewal. The Mayan long count calendar tracks periods of over 5,000 years, with each age terminating in catastrophe before a new world begins. Even the biblical account speaks of the earth being destroyed by fire at the end of days, followed by new heavens and a new earth. These are not random mythological concepts, but sophisticated models of cosmic time that recognize the cyclical nature of stellar violence. The ancients understood something that modern civilization has largely forgotten: that the universe operates on timescales far longer than human lifespans, and that events which seem impossibly rare to us are actually regular occurrences when viewed from a cosmic perspective. Solar physicists studying the long-term behavior of sun-like stars have confirmed this ancient wisdom. Superflare events follow predictable patterns tied to magnetic field reversals that occur roughly every 12,000 years. We are currently approaching the end of one such cycle, with solar activity showing signs of the instability that precedes major eruptions. The weakening of Earth's magnetic field, the increasing frequency of minor solar storms, and the unusual behavior of the sun's poles all suggest that we may be entering a period of heightened danger. The question is no longer whether another superflare will occur, but when, and whether our current civilization will be prepared for an event that could undo centuries of technological progress in a matter of hours. Unlike our ancestors who lived in small, self-sufficient communities that could survive independently, we have created a global civilization utterly dependent on electrical systems and satellite communications. A civilization that could collapse completely if the power grid fails for more than a few days. Yet within this vulnerability lies an opportunity. We are the first human civilization to understand the nature of the threat we face and to possess the technology to potentially defend against it. Hardened electronics, underground facilities, and distributed power systems could help preserve essential infrastructure through a superflare event. More importantly, we can encode our knowledge in multiple formats, from digital archives stored in electromagnetic-proof containers to physical monuments that could survive even the most extreme solar violence. The ancient monument builders left us a template for this work. They understood that knowledge preservation requires redundancy, that critical information must be encoded in multiple formats and locations to ensure survival. They carved their message in stone because stone endures when paper burns and metal melts. They embedded their data in mathematical relationships because mathematics is universalentible to comprehend any intelligence capable of measurement and calculation. We can do the same, but with technologies they could never have imagined. Digital storage systems protected by Faraday cages could preserve the entire contents of human knowledge through electromagnetic catastrophe. Genetic encoding could store information in DNA sequences designed to survive for millions of years. Quantum storage techniques might preserve data in crystalline matrices immune to radiation damage. But beyond technological solutions lies a deeper challenge. How do we prepare a global population for a catastrophe that most people cannot even imagine? How do we maintain the skills and knowledge necessary for survival in a post-technological world while continuing to advance the very US technologies that make vulnerable? How do we balance the benefits of our interconnected civilization with the risks of its fragility? The answer may lie in studying how previous civilizations navigated this same dilemma. The monument builders were not primitive peoples struggling with basic survival. They were the survivors of a technologically advanced world who had learned through bitter experience that all human achievements are temporary. They built their structures not as monuments to their own greatness, but as gifts to the future, insurance policies against the inevitable return of cosmic violence. Their greatest achievement was not the precision of their stonework or the accuracy of their astronomical alignments, but their recognition that knowledge must be preserved across timescales longer than any single civilization can survive. They understood that human progress is not a straight line, but a spiral, with each cycle building upon the preserved wisdom of those who came before. Modern climate science has revealed another layer to this cyclical pattern. The same cosmic radiation that accompanies superflare events can trigger rapid climate shifts by affecting cloud formation and atmospheric chemistry. The sudden cooling that ended the last ice age, the mysterious climate anomalies that brought down Bronze Age civilizations, and even the Little Ice Age of medieval times may all be connected to periods of increased solar activity followed by temporary stellar quieting. These climate shifts would have been as devastating as the electromagnetic effects themselves. Crop failures, mass migrations, and the collapse of trade networks would follow as reliably as technological breakdowns. The survivors would face not just the challenge of rebuilding their machines, but of adapting to an entirely transformed environment where the old agricultural techniques no longer worked and familiar weather patterns had vanished. Yet even these environmental catastrophes may have been anticipated by the ancient knowledge keepers. Many of the world's most mysterious monuments are located in regions that would remain habitable even during severe climate shifts. They are positioned near reliable water sources, in areas protected from extreme weather, and often at elevations that would remain above sea level even during periods of rapid ice melting. The builders may have been creating more than libraries of knowledge. They may have been establishing refuge points, locations where future survivors could gather to begin the work of rebuilding. The massive stone platforms that support many ancient temples could serve as foundations for post-catastrophe settlements. The astronomical alignments could function as calendars to help survivors track seasonal changes in a disrupted climate. The acoustic properties of temple chambers could enable communication across distances when electronic systems have failed. This interpretation casts the ancient monuments in an entirely new light. They are not relics of dead civilizations, but active systems, still waiting to fulfill their intended purpose. The knowledge they contain is not historical curiosity, but practical information that may soon become essential for human survival. The mathematical relationships carved into their stones could provide the foundation for rebuilding technology after electromagnetic destruction. The star charts embedded in their alignments could serve as navigation aids when GPS satellites have been destroyed. The irony is profound. The same cosmic force that may have destroyed previous advanced civilizations is approaching once again, and our best hope for survival may lie in understanding the warnings left by those who faced it before. We are like archaeologists racing against time, trying to decode messages left by our predecessors before we are forced to add our own chapter to the story of civilizations that rose, flourished, and faced the fury of an angry star. The next solar maximum is approaching, bringing with it the possibility of flares more powerful than any recorded in human history. Satellite measurements show our protective magnetic field continuing to weaken, leaving us increasingly vulnerable to cosmic radiation. Climate systems are showing signs of instability that may be linked to subtle changes in solar output. The ancient cycle may be completing its turn, bringing us full circle to another moment of cosmic reckoning. But this time, we are not entirely unprepared. The monuments left by our predecessors have given us warning of what is to come. The patterns they preserved in stone have revealed the cyclical nature of the threat we face. Their example has shown us that knowledge can survive even the most complete technological collapse if it is properly encoded and strategically placed. The question now is whether we will prove worthy students of their example, whether we will use the time remaining to prepare not just for our own survival, but for the survival of human knowledge itself. Whether we will follow their lead in building monuments not to our own glory, but to the future of our species. The sun continues its ancient dance, gathering energy for the next great release. The magnetic fields that protect us grow weaker with each passing year, and somewhere in the darkness between the stars, cosmic forces are aligning for another turn of the great wheel, another test of humanity's ability to preserve itself against the violence of the universe. The ancient builders understood this rhythm and prepared for it as best they could. Now it falls to us to honor their legacy by preparing for what they knew would come again. The sky may burn once more, but if we are wise enough to listen to the voices carved in stone, some small part of human knowledge and human hope may survive to see the stars return to their courses, and the long work of rebuilding begin anew. The survivors of such cosmic violence would emerge into a world transformed beyond recognition. The familiar constellations would still wheel overhead, but the landscape beneath would bear the scars of stellar fury. Where once forests stood, only charred stumps would remain. Rivers would run black with ash and debris. The very soil would be poisoned by exotic isotopes created when cosmic radiation tore apart the molecular bonds of organic matter. In this devastated world, the small bands of humans who managed to shelter through the catastrophe would face challenges their ancestors could never have imagined. The knowledge that had sustained their civilization would exist only in fragments, scattered memories held by traumatized survivors who had watched their world burn. Books would be ash, computers would be melted slag, and the vast libraries of human learning would exist only in the minds of those lucky or wise enough to have found adequate shelter. Yet even in this darkest scenario, hope would persist in unexpected forms. The massive stone structures that had puzzled archaeologists for generations would suddenly reveal their true purpose. Not temples to forgotten gods or monuments to ancient kings, but survival manuals carved in imperishable granite. Emergency instructions left by predecessors who had faced the same stellar violence and somehow endured. The precision-cut blocks would provide more than mere shelter. Their mathematical relationships would encode the fundamental constants of physics, allowing future scientists to rebuild technology from first principles. The astronomical alignments would serve as star maps, helping survivors navigate when magnetic compasses no longer functioned reliably in the disrupted magnetic field. The acoustic chambers would amplify human voices across distances when electronic communication had become impossible. But perhaps most importantly, these structures would provide something even more valuable than practical knowledge. They would offer proof that recovery was possible, that civilizations could rise from ashes and reach toward the stars once again. The very existence of such sophisticated monuments built by hands that had known fire from the sky would serve as beacons of hope for survivors struggling to comprehend the magnitude of their loss. Archaeological evidence suggests this cycle of destruction and renewal has played out multiple times throughout human history. The mysterious gaps in the archaeological record, periods when advanced cultures simply vanish from the fossil record only to be replaced by seemingly primitive peoples with entirely different technologies, may mark the boundaries between stellar ages. Each gap represents not just cultural change, but cosmic catastrophe followed by desperate rebuilding. The Bronze Age collapse around 1200 BCE provides a historical example of how quickly complex civilizations can disintegrate when their technological foundations are undermined. Within a few generations, the sophisticated palace cultures of the Eastern Mediterranean had vanished. Their writing systems were forgotten, their trade networks collapsed, and their urban centers were abandoned. When new civilizations emerged from the chaos centuries later, they had to rediscover everything from metallurgy to navigation. But that collapse was caused by relatively minor disruptions compared to what a true solar superflare could unleash. Earthquakes, invasions, and climate shifts can destroy cities and topple kingdoms, but they leave the fundamental knowledge intact. Books can be recopied, technologies can be reinvented, and survivors can rebuild using techniques they still remember. A superflare would be different. It would erase not just the products of civilization, but the memory of how to create them. In such a scenario, the survivors would find themselves in the position of archaeologists, trying to decode the remnants of their own culture. The twisted metal and melted glass of modern cities would be as mysterious to them as ancient ruins are to us today. They would struggle to understand how their ancestors had managed to fly through the air, communicate across oceans, or harness electricity to power vast urban centers. The irony would be profound. The most advanced civilization in human history would leave behind the least comprehensible ruins. Our electronic devices, so sophisticated that they seem like magic even to their users, would be reduced to incomprehensible fragments. Our digital libraries, containing the accumulated knowledge of millennia, would vanish without a trace. Future archaeologists sifting through our remains might conclude that we were primitives who somehow stumbled upon a few advanced technologies without truly understanding them. But scattered among the debris of our technological civilization, they would find older artifacts that had somehow survived the electromagnetic storm. Stone monuments whose builders had anticipated exactly this scenario. Ancient libraries encoded not in fragile media, but in relationships between massive blocks of granite and basalt. Mathematical constants preserved not in books that could burn, but in ratios that would endure as long as the stones themselves remained standing. These monuments would become the foundation stones of the next civilization, just as they may have served previous cycles of human development. The survivors would gather around them, studying their alignments and proportions, slowly decoding the messages left by those who had prepared for this exact moment. Generation by generation, they would piece together the fragments of lost knowledge, using the ancient templates to guide their rebuilding efforts. The process would not be easy or quick. Centuries might pass before the survivors developed writing systems sophisticated enough to record their discoveries. Millennia could elapse before they regained the ability to work metals or navigate by the stars. The knowledge preserved in stone would have to be rediscovered gradually, each insight building upon the last, as the new civilization slowly climbed back toward technological sophistication. But the path would not be entirely unknown. The ancient builders had walked it before and left markers along the way. The same geometric principles that allowed them to construct earthquake-resistant temples could guide the rebuilding of stable architecture. The astronomical observations embedded in their monuments could help restore accurate calendars and navigation systems. The mathematical relationships they preserved could provide shortcuts to rediscovering everything, from agriculture to metallurgy. Modern physicists studying these ancient structures have begun to appreciate the sophistication of the knowledge they contain. The builders understood principles of resonance, harmonic ratios, and structural engineering that were not formally rediscovered until the modern era. They encoded information about Earth's dimensions, the precession of the equinoxes, and the relationships between planetary and stellar motions with an accuracy that rivals contemporary measurements. This suggests that the civilization that created these monuments was not primitive at all, but was operating from a knowledge base at least as sophisticated as our own. They understood the cosmos not through instruments and calculations alone, but through a deeper comprehension of the mathematical harmony that underlies physical reality. Their monuments were not just practical survival tools, but expressions of a profound understanding of humanity's place within the cosmic order. The implications are staggering. If these structures were indeed built by survivors of previous superflare events, then human civilization may be far older than we imagine. The steady progression from stone tools to space travel that we celebrate as the triumph of human ingenuity may actually be just the latest iteration of a cycle that has repeated many times. We may not be the first humans to split the atom, explore the solar system, or contemplate the nature of the universe. We may be following in the footsteps of predecessors who achieved the same milestones before seeing their achievements reduced to ash by stellar violence. This cyclical view of human progress offers both comfort and warning. Comfort in the knowledge that recovery is possible, that human ingenuity and determination can rebuild even from the most complete devastation. Warning in the recognition that all technological achievements are temporary, that the cosmic forces that destroyed previous civilizations remain as active today as they were millennia ago. The ancient monument builders seem to have understood both aspects of this reality. Their structures express confidence in human potential while acknowledging the fragility of human achievements. They built for the long term, encoding their knowledge in forms that could survive not just centuries, but geological ages. Yet they also built with urgency, as though they understood that time was limited and the next catastrophe was always approaching. Modern astronomy is beginning to confirm their concerns. Solar observatories around the world are detecting signs of increasing instability in our star's magnetic field. The protective magnetosphere that shields Earth from cosmic radiation is weakening at an accelerating rate. Satellite measurements show gaps appearing in our magnetic defenses, temporary windows through which deadly particles can penetrate to the surface. Even more ominously, the sun's behavior is becoming increasingly erratic. The regular 11-year cycle of solar activity that has persisted throughout recorded history is showing signs of disruption. Solar physicists studying the patterns of sunspot formation and coronal mass ejections have identified anomalies that suggest we may be entering a period of enhanced stellar activity. The magnetic dynamo that drives solar flares appears to be building toward a configuration not seen in thousands of years. Computer models of extreme solar events paint an increasingly urgent picture. The same magnetic field reversals that trigger superflares in other sun-like stars are beginning to manifest in our own solar system. The precise timing remains uncertain, but the underlying physics suggests that a major eruption could occur within decades rather than centuries. We may be the generation that finally faces the cosmic test that previous civilizations failed to survive. Yet we also possess advantages that our predecessors lacked. We understand the nature of electromagnetic radiation and can build devices to detect and measure solar activity with unprecedented precision. We have developed materials and techniques that could potentially shield critical infrastructure from all but the most extreme cosmic events. Most importantly, we have global communication systems that could coordinate survival efforts across continents, ensuring that knowledge and resources are distributed widely enough to survive even catastrophic losses. The challenge lies not in our technological capabilities, but in our psychological readiness. Modern civilization has grown comfortable with the illusion of permanence, the belief that our achievements represent the natural culmination of human progress, rather than temporary constructions vulnerable to cosmic disruption. We struggle to think in timescales longer than quarterly earnings reports or election cycles, let alone the millennia over which stellar violence operates. The ancient builders faced no such limitations. Their monuments demonstrate a planning horizon that extends across multiple stellar cycles, a willingness to invest enormous resources in projects whose benefits would not be realized for thousands of years. They understood that true civilization is measured not by what a single generation achieves, but by what it preserves for future generations to build upon. This long-term perspective becomes increasingly relevant as we approach what may be another turning point in the cosmic cycle. The question is not whether another superflare will occur, but whether we will be prepared when it does. Whether we will follow the example of the monument builders and create systems capable of preserving human knowledge across stellar catastrophe. Whether we will prove worthy inheritors of their legacy by adding our own contributions to the great work of ensuring human survival. The evidence suggests we still have time to prepare, but that time is growing short. The solar weakening and the signs of instability, our multiple cycle is accelerating, the magnetic field icing. We may have decades to build the hardened infrastructure and distributed knowledge systems that could allow our civilization to survive what previous cultures could not. But those decades will pass quickly, and the work required is enormous. The ancient builders left us more than warnings encoded in stone. They left us a template for survival, a demonstration that human knowledge and human hope can endure even the most complete technological collapse. Their monuments stand as proof that preparation is possible, that foresight and determination can create legacies that outlast stars themselves. The sun burns in the sky above us now, as deceptively peaceful as it has appeared for all of recorded history. But deep within its nuclear heart, forces are building that could transform our comfortable world into something our grandparents would not recognize. The ancient cycle is turning once again, and we are the generation chosen to face its test. Whether we meet that challenge successfully will depend not on our technology alone, but on our wisdom, on our ability to learn from those who faced this trial before us and left instructions carved in stone for those who would come after, on our willingness to think beyond our own brief lifespans and build for futures we will never see, on our recognition that we are not the culmination of human achievement, but merely the latest chapter in a story that began long before us and must continue long after we are gone. The monuments wait in the desert, their messages still largely unread. The sun gathers its strength for the next great release, and somewhere in the space between earth and sky, the future of human civilization hangs in the balance, awaiting our decision to either heed the warnings of the past or ignore them and face the consequences alone. The mathematics of survival become clearer when we examine the infrastructure that connects our modern world. Every major city on Earth depends on electrical grids so complex that their failure would cascade through society like dominoes falling in perfect sequence. The transformers that regulate power across continental distances are custom-built machines that take years to manufacture and replace. A single superflare could destroy thousands of them simultaneously, leaving entire regions without electricity for decades rather than days. Consider the supply chains that keep 8 billion people fed. Modern agriculture depends entirely on fossil fuels for tractors, synthetic fertilizers manufactured in chemical plants, and refrigerated transport systems that move food across thousands of miles. Without electricity to power these networks, even fertile regions would struggle to support their local populations. Urban centers, built to house millions in spaces that could naturally sustain only thousands, would become uninhabitable within weeks. The medical infrastructure that extends human lifespan would collapse just as completely. Hospitals depend on electricity not just for lighting and equipment, but for the manufacture and distribution of pharmaceuticals that keep millions alive. Insulin for diabetics, medications for heart conditions, treatments for cancer, all require industrial processes that would vanish the moment the power grid failed. Within months, diseases that modern medicine has rendered manageable would return to claim lives on a scale not seen since the medieval era. Yet perhaps the most devastating loss would be invisible to those experiencing it. The collapse of satellite networks would eliminate GPS navigation, weather forecasting, and global communication simultaneously. Ships would lose their ability to navigate precisely across open oceans. Aircraft would be grounded not just by electromagnetic damage, but by the loss of air traffic control systems. Even automobiles, increasingly dependent on GPS and electronic systems, would become unreliable in a world where magnetic compasses spin wildly due to disrupted magnetic fields. The psychological impact of such comprehensive technological failure would be as destructive as the physical effects. Billions of people who have never lived without electricity, internet access, and global supply chains would find themselves thrust into conditions their ancestors faced routinely. The skills that sustained human civilization for millennia, how to preserve food without refrigeration, navigate by stars, or maintain health without modern medicine, exist now only in the memories of elderly populations and the pages of books that would themselves be destroyed. But within this catastrophic scenario lies a pattern that repeats throughout the archaeological record. Civilizations that seem to vanish overnight, leaving behind only scattered artifacts and mysterious ruins. The Indus Valley Civilization, which flourished for over 1,000 years with sophisticated urban planning and trade networks, disappeared so completely that we still cannot read their script. The Mycenaean Greeks, who built massive stone fortresses and traded across the Mediterranean, vanished so thoroughly that later Greeks remembered them only in myths of heroes and gods. In each case, the disappearance was not gradual decline, but sudden collapse. Thriving cities were abandoned within a single generation. Complex technologies were forgotten so completely that later inhabitants could not comprehend how the monuments around them had been built. The survivors reverted to simpler lifestyles, often interpreting the ruins of their predecessors as the work of giants or gods rather than human hands. Modern archaeology has struggled to explain these rapid collapses, usually attributing them to warfare, climate change, or internal social conflicts. But the global pattern of simultaneous disruption suggests a common cause that affected all civilizations, regardless of their location or cultural development. Something that could bring down the Bronze Age palaces of Greece at the same time as the urban centers of the Indus Valley, despite the thousands of miles that separated them. The isotope spikes found in ice cores from these periods tell a consistent story. Each major civilizational collapse coincides with evidence of intense cosmic radiation bombardment. The same signature that appears in the geological record around 12,800 years ago repeats at intervals throughout human history, marking the boundaries between ages. It's as though the cosmos itself operates on a schedule, delivering periodic resets to terrestrial civilization with the regularity of a cosmic clock. Solar physicists studying other sun-like stars have begun to understand this rhythm. The magnetic dynamos that drive stellar activity operate on multiple overlapping cycles, some lasting decades, others spanning millennia. When these cycles align in certain configurations, the results can be explosive. Stars that appear stable for centuries can suddenly unleash flares thousands of times more powerful than their normal output, transforming peaceful solar systems into radiation-blasted wastelands. Our own sun shows clear evidence of participating in this cosmic rhythm. Paleomagnetic data from volcanic rocks reveal that Earth's magnetic field has reversed its polarity hundreds of times throughout geological history, always in conjunction with periods of increased solar activity. These reversals don't happen gradually but occur rapidly, sometimes within a human lifetime. During the transition periods, when the magnetic field is weak and unstable, the planet becomes vulnerable to cosmic radiation that would normally be deflected safely into space. We may be entering such a transition period now. The magnetic North Pole has been moving at an accelerating pace, shifting hundreds of miles in recent decades. The overall strength of Earth's magnetic field has decreased by 15% over the past 2 centuries, with the rate of decline accelerating in recent years. Satellite measurements reveal expanding areas where the magnetic field is so weak that cosmic radiation can penetrate to the upper atmosphere, creating aurora displays at latitudes where they were never seen before. These changes coincide with unusual solar behavior that has solar physicists increasingly concerned. The sun's magnetic field, which normally reverses polarity every 11 years in a predictable cycle, has been showing signs of instability. The most recent reversal was delayed and incomplete, leaving the solar magnetic field in a configuration not observed in recorded history. Computer models suggest this could be the precursor to a much more dramatic magnetic reorganization, one that could trigger superflare activity on a scale not seen for thousands of years. The timing is particularly ominous when viewed against the backdrop of human technological development. We have reached a level of complexity and interdependence that makes us more vulnerable to electromagnetic disruption than any previous civilization. Yet we have also developed the scientific understanding and technological capabilities that could potentially allow us to survive what our predecessors could not. The question is whether we will use these advantages wisely or repeat the same cycle of unprepared collapse that has claimed every advanced civilization before us. The ancient monument builders seem to have faced this same choice and made their decision deliberately. Rather than trusting that their technological achievements would somehow survive cosmic catastrophe, they invested enormous resources in creating backup systems carved from materials that could endure stellar violence. Their temples and pyramids were not religious monuments, but practical preparations for civilizational collapse, encoding essential knowledge in forms that would remain readable even after all books had burned and all electronic systems had failed. The precision of their work suggests they understood exactly what they were preparing for. The mathematical relationships embedded in their structures are not random artistic choices, but specific information encoded for future recovery. The golden ratio appears repeatedly because it represents fundamental relationships in natural growth patterns that would remain constant even after technological collapse. The astronomical alignments preserve star charts that could serve as navigation aids when GPS satellites had been destroyed. Even the choice of materials was deliberate. Granite and other hard stones were selected not just for their durability, but for their resistance to electromagnetic effects. Unlike softer limestone or marble, granite contains high concentrations of quartz crystals that can survive intense radiation without significant damage. The builders were creating archives that could endure not just millennia, but geological ages, information storage systems designed to outlast the very mountains they were carved from. The acoustic properties of their chambers may have served a similar preservation function. Sound travels through stone more efficiently than through air, allowing messages to be transmitted across distances without electronic amplification. The resonant frequencies of temple chambers could serve as communication networks for scattered survivors trying to coordinate rebuilding efforts. Even the specific tones that these structures amplify may have been chosen for their effects on human consciousness, creating states of heightened awareness that could help survivors access and retain crucial information during the chaotic aftermath of catastrophe. Modern neuroscience has begun to understand how these acoustic effects work. Specific frequencies can alter brainwave patterns, potentially enhancing memory formation and recall. The same tones that cause temple chambers to resonate naturally also correspond to the frequencies that promote deep meditative states in human consciousness. The ancient builders may have been creating not just information storage systems, but psychological tools designed to help future survivors access and utilize preserved knowledge more effectively. This integration of technology and consciousness represents a sophistication that goes far beyond what we typically associate with prehistoric cultures. The builders were not primitive peoples struggling with basic survival, but representatives of an advanced civilization that understood both the physical and psychological dimensions of knowledge preservation. They created systems that could function on multiple levels simultaneously, serving practical needs while also addressing the deeper human requirements for meaning and continuity across cosmic timescales. The implications for our current situation are profound. We possess technologies that the ancient builders could never have imagined, but we have largely ignored the psychological and social dimensions of survival that they understood intuitively. Our backup systems are focused on preserving data and maintaining infrastructure, but we have given little thought to how survivors would actually access and use preserved information in the chaotic aftermath of civilizational collapse. The ancient approach suggests that effective preparation requires more than just technical solutions. It demands a fundamental shift in how we think about knowledge, progress, and human continuity. Instead of viewing our achievements as the inevitable result of linear development, we need to understand them as temporary constructions that require constant protection and renewal. Instead of assuming that future generations will naturally build upon our work, we need to actively prepare them for the possibility that they may have to start over from basics. This perspective transforms how we evaluate current threats and opportunities. Climate change, political instability, and economic uncertainty are certainly serious challenges, but they pale in comparison to the cosmic forces that have repeatedly reset human civilization throughout history. A superflare event would make all our current problems irrelevant by destroying the technological foundation that supports 8 billion people. Preparing for such an event requires thinking on timescales and scales that dwarf our normal planning horizons. Yet the same long-term perspective that reveals the magnitude of the threat also suggests strategies for addressing it. If human civilization has risen from ashes before, it can do so again. If knowledge has been successfully preserved across previous cosmic catastrophes, we can improve upon those preservation techniques using modern understanding and capabilities. If survivors have rebuilt advanced societies from scattered remnants, we can prepare more comprehensive remnants for future survivors to discover. The key insight from studying ancient monuments is that effective preparation requires redundancy and distribution. No single archive or storage system can guarantee survival through cosmic catastrophe. Knowledge must be preserved in multiple formats, stored in numerous locations, and encoded at different levels of complexity to ensure that at least some information survives even the most complete technological collapse. The builders understood this principle and implemented it on a scale that spanned continents and millennia. Modern information theory provides tools for applying this principle more systematically than ever before. We can create storage systems that combine the durability of stone monuments with the information density of digital media. Crystalline matrices could preserve vast databases in forms resistant to electromagnetic interference. Genetic encoding could store information in DNA sequences designed to survive for millions of years. Quantum storage techniques might preserve data in atomic structures immune to all but the most extreme cosmic events. But beyond technological approaches lies a more fundamental challenge. How do we create cultural systems that can maintain essential knowledge across generational timelines? How do we ensure that the skills needed for post-catastrophe survival remain alive in human communities even as those communities become increasingly dependent on technologies that cosmic events could destroy? How do we balance the benefits of technological advancement with the risks of civilizational fragility? The monument builders faced these same questions and developed sophisticated solutions. They created educational systems that transmitted essential knowledge through multiple channels simultaneously. Mathematical principles were embedded in architectural relationships, astronomical observations were encoded in stone alignments, and practical skills were preserved through ritual practices that ensured their continuous transmission across generations. They understood that knowledge preservation requires not just storage systems, but living traditions that keep information active and accessible. Their approach suggests that preparing for cosmic catastrophe requires more than just building hardened infrastructure or creating backup databases. It demands the cultivation of human capabilities and cultural practices that can function independently of technological support. Skills like navigation by stars, food preservation without refrigeration, and communication without electronics need to be maintained as living knowledge rather than historical curiosities. Communities need to develop the social structures and psychological resilience that could sustain them through the collapse of familiar support systems. This cultural preparation becomes increasingly urgent as we approach what may be another turning point in the cosmic cycle. The signs of solar instability are multiplying, the protective magnetic field continues to weaken, and the technological systems that support modern civilization become more complex and interdependent with each passing year. We may have only decades to implement the kind of comprehensive preparation that could allow human knowledge and human communities to survive the next great stellar outburst. The ancient monuments stand as proof that such preparation is possible and that its effects can last for thousands of years. Their builders faced the same cosmic forces we now confront and found ways to preserve what mattered most across the greatest catastrophe imaginable. They left us not just warnings, but examples, demonstrations of how foresight and determination can create legacies that outlast the civilizations that created them. The question now is whether we will prove worthy of their example by creating our own contributions to the great work of ensuring human survival across cosmic time. The stars wheel overhead in their ancient patterns, indifferent to human hopes and fears, but bound by the same physical laws that govern stellar violence and planetary protection. Somewhere among those distant lights burn stars similar to our sun, stars that have already experienced the kind of superflare events that may await us. Their planets, if any exist, either lie barren under radiation-blasted skies or harbor life forms that have learned to survive cosmic fury through preparation and wisdom. We cannot know which fate awaits our own world, but we can influence the outcome through the choices we make in the time remaining. The cosmic clock continues its ancient rhythm, But human consciousness and human will remain free to act within the constraints that physics imposes. We can choose to heed the warnings carved in stone by our predecessors, or we can ignore them and face the consequences unprepared. We can choose to build for permanence across cosmic timescales, or we can remain focused on temporary achievements that stellar violence could erase in moments. The monuments wait in silence, their messages still only partially decoded. The sun gathers energy for its next great release, following patterns established long before Earth itself existed. And in the space between stone and star, between ancient wisdom and future catastrophe, human civilization continues its precarious dance on the edge of cosmic time. The dance grows more urgent with each passing season. Satellite networks that once seemed permanent fixtures in our sky begin to flicker and fail with increasing frequency. Space weather alerts, once rare scientific curiosities, now interrupt regular broadcasts with warnings of magnetic storms and radiation hazards. The International Space Station routinely shelters its crew in shielded compartments as charged particles stream past Earth's weakening defenses. Yet most of humanity continues its daily routines, unaware that the cosmic dice are rolling toward a combination that could end the game entirely. Deep beneath the surface of our seemingly stable world, geological processes are responding to forces that originate 93 million miles away. The molten iron core that generates Earth's protective magnetic field operates according to principles that connect it directly to solar activity. When our star's magnetic field undergoes major reorganizations, the effects cascade through the solar system like ripples in a cosmic pond. Earth's core feels these disturbances and responds with changes in the magnetic dynamo that shields us from cosmic radiation. Recent measurements from magnetic observatories around the globe paint an increasingly troubling picture. The South Atlantic anomaly, a region where Earth's magnetic field is particularly weak, has been expanding and deepening at an accelerating rate. Satellite operators have learned to power down sensitive electronics when their spacecraft pass through this zone, but the affected area grows larger each year. Computer models suggest that if current trends continue, multiple such weak zones could merge into vast regions where cosmic radiation reaches the surface with deadly intensity. The implications extend far beyond satellite operations. Commercial aviation routes already avoid polar regions during periods of high solar activity, when radiation levels can expose passengers and crew to dangerous doses. As Earth's magnetic protection continues to deteriorate, these no-fly zones could expand to encompass major flight corridors, effectively cutting off air travel between continents. The global economy, built on the assumption of rapid transportation and communication, would face disruptions that could cascade into complete systemic collapse. Marine navigation systems would suffer similarly catastrophic failures. The GPS constellation that guides everything from cargo ships to fishing boats depends on precise timing signals from satellites orbiting above the worst effects of atmospheric interference. But these same satellites are increasingly vulnerable to radiation damage that could knock them offline permanently. Without GPS guidance, modern shipping would revert to celestial navigation techniques that few contemporary mariners have learned. The just-in-time supply chains that feed cities and fuel industries would break down as cargo vessels struggle to find their destinations in a world where electronic liable. The financial navigation had become unreal. Global commerce would face networks that enable even more immediate threats. High-frequency trading systems that execute millions of transactions per second depend on communication links that travel through the same satellite networks vulnerable to solar radiation. Banking systems that process electronic payments across continents rely on precise timing signals that cosmic interference could disrupt. Even terrestrial fiber optic cables, buried deep underground, could fail if the electronic repeaters that boost signals across long distances were damaged by electromagnetic pulses traveling through the Earth itself. Yet these technological vulnerabilities, severe as they are, represent only the most visible aspects of our civilization's fragility. The deeper threat lies in the knowledge systems that underpin modern society. Unlike the ancient monument builders, who encoded essential information in multiple durable formats, we have concentrated our accumulated wisdom in electronic databases that exist only as patterns of magnetic orientation on spinning disks and electrical charges in semiconductor memories. When those patterns are disrupted by electromagnetic interference, the information they represent simply vanishes. Consider the practical implications of such comprehensive data loss. Medical records that track medication allergies and treatment histories would disappear, leaving doctors unable to provide safe care for patients with complex conditions. Engineering specifications for critical infrastructure would vanish, making repair and maintenance impossible without costly and time-consuming reverse engineering. Scientific data gathered over decades of careful observation would be lost, forcing researchers to begin again from basic principles. The educational systems that transmit knowledge to new generations would face equally devastating disruption. Digital textbooks, online courses, and electronic libraries that have replaced physical books in many institutions would become inaccessible the moment their storage systems failed. Teachers trained to use interactive whiteboards and computer-assisted learning would find themselves without the tools they have come to depend upon. Students who have never learned to research topics without internet access would struggle to continue their education using only printed materials, assuming such materials had survived the electromagnetic catastrophe. Even more fundamentally, the social structures that maintain order and cooperation in complex societies depend increasingly on electronic communication and record-keeping. Government databases that track citizenship, property ownership, and legal obligations exist primarily in digital formats that cosmic radiation could erase instantly. The systems that coordinate emergency services, distribute social benefits, and maintain law enforcement would collapse if their electronic foundations were destroyed. In the chaotic aftermath of such comprehensive system failure, maintaining social cohesion would become far more challenging than rebuilding physical infrastructure. The psychological trauma of such complete technological collapse would compound all other difficulties. Billions of people who have never experienced life without electricity, internet connectivity, and electronic devices would find themselves thrust into conditions that their ancestors navigated successfully, but which they are utterly unprepared to handle. The learned helplessness that comes from depending entirely on systems beyond individual control would paralyze many survivors, preventing them from taking the initiative needed for effective recovery efforts. Yet within this seemingly hopeless scenario lies a pattern that offers both warning and hope. Archaeological evidence suggests that previous technological collapses, while devastating in the short term, have also served as catalysts for cultural evolution and adaptation. The survivors of such events have often developed more resilient social structures and more diversified knowledge systems than the civilizations they replaced. The necessity of rebuilding from scattered remnants has forced human communities to rediscover forgotten skills and develop innovative solutions to fundamental survival challenges. The Dark Ages that followed the fall of the Roman Empire provide a historical example of how societies can adapt to the loss of complex technological systems. As urban centers collapsed and trade networks disintegrated, rural communities developed self-sufficient agricultural practices that could sustain local populations without external support. Monasteries and other religious institutions became repositories of preserved knowledge, maintaining libraries and educational traditions through centuries of political chaos. When stability eventually returned, these scattered centers of learning became the foundation for cultural renaissance and technological advancement. But the collapse that a solar superflare could trigger would be far more complete than anything experienced during historical periods. The electromagnetic effects would destroy not just the technological systems that support modern civilization, but potentially the knowledge needed to rebuild them. Unlike the libraries that preserved classical learning through the Dark Ages, our digital archives offer no protection against cosmic radiation. The monks who hand-copied manuscripts to preserve ancient wisdom have been replaced by automated systems that would fail the moment their electronic brains were fried by solar fury. This recognition has led some forward-thinking organizations to begin developing what they call digital monasteries, hardened facilities designed to preserve essential human knowledge through electromagnetic catastrophe. These installations combine the durability of undergrounders with the information density of modern storage systems, creating archives that could survive even direct nuclear attack or extreme solar activity. Redundant systems ensure that critical data exists in multiple formats and locations, while carefully selected human communities maintain the skills needed to access and utilize preserved information. The challenge lies in determining what knowledge deserves such expensive protection. The sum total of human learning has grown beyond the capacity of any single archive to contain, forcing difficult choices about priorities and preservation strategies. Scientific principles and mathematical relationships that describe fundamental natural laws clearly merit protection, as do the practical skills needed for basic survival and civilization building. But what about literature, art, music, and the other cultural achievements that give human life meaning beyond mere survival? The ancient monument builders faced similar choices and developed sophisticated criteria for selection. They preserved mathematical constants because these relationships remain true regardless of technological context. They encoded astronomical observations because celestial navigation and calendar systems are essential for any civilization that hopes to advance beyond subsistence level. They embedded practical information about construction techniques, agricultural cycles, and resource management because survival requires mastery of the physical environment. But they also preserve something less tangible but equally important. The monuments themselves embody principles of harmony, proportion, and beauty that speak to fundamental aspects of human consciousness. The mathematical relationships that govern their construction are the same ratios that appear in music, art, and natural growth patterns. By encoding these principles in stone, the builders ensured that future civilizations would rediscover not knowledge just practical, but the aesthetic and spiritual dimensions that make human culture worth preserving. This integration of practical and transcendent knowledge represents a sophistication that goes beyond mere information storage. The builders understood that effective cultural transmission requires more than just facts and techniques. It demands the preservation of values, motivations, and meaning systems that inspire people to use knowledge constructively rather than destructively. A civilization that recovers only technical capabilities without the wisdom to apply them responsibly might create even greater catastrophes than the cosmic events that destroyed their predecessors. Modern preservation efforts must grapple with these same challenges while utilizing technologies and insights unavailable to ancient builders. We can create storage systems with vastly greater information density than stone monuments, but we must ensure that the knowledge they contain remains accessible across the kind of technological discontinuities that solar superflares could create. We can distribute archives globally to minimize the risk of total loss, but we must also maintain the human communities capable of utilizing preserved information effectively. The task becomes more urgent as signs of impending solar instability multiply. Space weather monitoring stations around the world report increasingly frequent and intense magnetic storms. The aurora displays that once appeared only near polar regions now extend to latitudes where they have never been recorded in historical times. Even more ominously, sensitive instruments designed to detect cosmic ray bombardment are registering levels that approach the thresholds associated with extreme solar events. Solar physicists studying these phenomena warn that the current solar cycle may be building toward a maximum far more intense than any previously observed. The magnetic field reversals that trigger superflare activity in other sun-like stars are showing similar patterns in our own solar system. Computer models that incorporate recent observations suggest a significant probability of major solar eruption within the next several decades, possibly within the current generation's lifetime. The window for effective preparation may be narrowing rapidly. The hardened infrastructure and distributed knowledge systems that could help civilization survive cosmic catastrophe require years or decades to implement properly. The cultural changes needed to maintain essential skills and social structures in post-technological environments require even longer timescales to take root effectively. If the ancient patterns hold true, we may have only a brief period of relative stability before the cosmic cycle completes another revolution and tests humanity's resilience once again. The choice before us mirrors the one faced by every advanced civilization that has encountered this threshold. We can continue building increasingly complex and interdependent systems that maximize short-term efficiency while creating catastrophic vulnerabilities to cosmic disruption. Or we can follow the example of the monument builders and invest in preservation strategies that prioritize long-term survival over immediate convenience. We can trust that technological solutions will somehow emerge to protect us from stellar violence. Or we can accept the cyclical nature of cosmic events and prepare accordingly. The stakes could not be higher. This may be humanity's first opportunity to face cosmic catastrophe with full scientific understanding of the forces involved and technological capabilities that could potentially ensure survival. Previous civilizations met this test with stone tools and muscle power, yet some managed to preserve essential knowledge across the greatest disasters imaginable. We possess resources and insights that dwarf theirs, but we also face vulnerabilities they never had to consider. The monuments they left behind continue to offer guidance for those wise enough to study their example, not just in the specific information they preserve, but in the principles that guided their construction. Redundancy over efficiency, durability over convenience, wisdom over mere knowledge, community resilience over individual achievement. These values, encoded in stone relationships and geometric harmonies, represent a philosophy of survival that transcends any particular technological context. As solar activity builds toward its next great crescendo and Earth's magnetic defenses continue their accelerating decline, we face the same eternal choice between preparation and complacency, between building for permanence and building for profit, between preserving what matters most and trusting that somehow everything will work out. The ancient builders made their choice and left the results for us to discover. The cosmic forces that tested them are gathering strength once again, and soon it will be our turn to choose how we meet the challenge they represent. The future waits in the balance between stellar fury and human wisdom, between the violence of cosmic forces and the resilience of conscious preparation. In that balance lies the fate not just of our current civilization, but of all the knowledge, beauty, and hope that human consciousness has managed to create during its brief moment under the stars. The next chapter in this cosmic story will be written by our response to warnings carved in stone by those who faced the fire before us, and somehow found the strength to ensure that their wisdom would survive to guide us through the trials ahead. The monuments stand silent in the desert wind, their surfaces warming under a sun that seems no different today than it did 1,000 years ago. Yet beneath that deceptive calm, forces are building that could transform our world as completely as they have transformed countless worlds before us. The question is no longer whether another cosmic catastrophe will occur, but whether we will recognize the signs in time to prepare for what the ancient builders knew was inevitable. In the laboratories of space weather research centers, scientists monitor instruments that measure the sun's magnetic field with unprecedented precision. These devices reveal subtle changes in solar behavior that previous generations could never have detected. The magnetic loops that rise from the sun's surface are growing larger and more unstable. The coronal holes that allow high-speed solar wind to escape into space are expanding at rates that concern even the most experienced solar physicists. Most troubling of all, the overall magnetic field that normally constrains solar eruptions is showing signs of the kind of reorganization that precedes the most violent stellar outbursts. The data streams flowing from solar observatories paint a picture of accelerating instability. Where once the sun's magnetic field reversed polarity in predictable 11-year cycles, recent measurements show irregularities that suggest a much more dramatic transition may be approaching. The magnetic field lines that normally constrain solar plasma in stable configurations are becoming twisted and tangled in ways that create enormous stores of potential energy. When these magnetic structures finally snap and reconfigure themselves, the release of energy could dwarf anything in recorded human experience. Computer simulations based on current observations suggest that we may be witnessing the early stages of a magnetic field reversal far more complete than the routine solar cycle changes. Such reversals, while rare, have been observed in other sun-like stars and invariably produce superflare events that release energy equivalent to billions of nuclear weapons detonating simultaneously. The electromagnetic radiation and charged particles from such an eruption would reach Earth within hours, overwhelming our magnetic defenses and plunging the planet into a new dark age. The warning signs extend beyond solar observations to Earth's own magnetic field, which serves as our first line of defense against cosmic radiation. Magnetic observatories scattered across the globe report that the field strength has been declining steadily for over a century, with the rate of decline accelerating in recent decades. The magnetic North Pole, once stable enough to serve as a reliable navigation reference, now wanders hundreds of miles each year as the field configuration becomes increasingly chaotic. Satellite measurements reveal the formation of multiple weak zones in Earth's magnetic field, areas where cosmic radiation can penetrate much deeper into the atmosphere than normal. These anomalies, once confined to small regions over the South Atlantic, are now appearing at various latitudes and growing larger each year. Astronauts aboard the International Space Station routinely take shelter in shielded compartments when passing through these zones. But ground-based populations have no such protection when the weakened field allows dangerous radiation to reach the surface. The convergence of solar instability and magnetic field weakness creates a scenario that solar physicists describe as a perfect storm. Even relatively moderate solar events that would normally be deflected harmlessly into space could penetrate Earth's weakened defenses and cause widespread technological disruption. A truly major solar eruption, occurring when our magnetic field is at its weakest point in recorded history, could overwhelm all natural and artificial protective systems simultaneously. The geological record suggests that such convergences have occurred before, with devastating consequences for whatever civilizations existed at the time. Ice core data from Greenland and Antarctica reveal spikes in cosmic ray bombardment that coincide with major cultural transitions throughout human history. The mysterious collapse of Bronze Age civilizations around 1200 BCE, the fall of the Roman Empire, and even the plague outbreaks of the medieval period all occurred during periods when tree ring data shows evidence of intense solar activity and cosmic ray exposure. But these historical events, severe as they were, occurred when human societies were far less dependent on electrical systems than they are today. The electromagnetic pulses that could disrupt bronze tools or interfere with magnetic compass navigation would have devastating effects on modern electronics. Every computer, communication system, and power grid on Earth relies on delicate electronic components that would be instantly destroyed by the kind of electromagnetic bombardment that a major solar event could produce. The cascading failures that would follow such comprehensive electromagnetic destruction would affect every aspect of modern life within hours. Banking systems would collapse as electronic records were wiped out and transaction networks went offline. Transportation systems would fail as traffic control systems, GPS navigation and electronic engine management systems stopped functioning. Medical facilities would lose access to patient records, diagnostic equipment, and life support systems that keep millions of people alive. Food distribution networks, already operating on thin margins with just-in-time delivery systems, would break down as inventory tracking systems failed and refrigerated transport became impossible. Urban populations, dependent on constant resupply from distant agricultural regions, would face shortages within days. The social order that depends on electronic communication and record-keeping would begin to fragment as coordination between government agencies, emergency services, and relief organizations became impossible. Yet within this scenario of technological collapse lies a deeper pattern that connects our situation to the experiences of previous civilizations. The archaeological evidence suggests that advanced societies have faced similar challenges before, and that some have managed to preserve essential knowledge through the most complete disasters. The precision-built monuments that dot our planet may not be primitive attempts at religious expression, but sophisticated information storage systems designed by people who understood exactly what kind of catastrophe they were preparing for. The mathematical relationships encoded in these structures preserve more than abstract knowledge. They contain practical information about astronomy, engineering, and resource management that could serve as the foundation for rebuilding technological civilization after electromagnetic catastrophe. The astronomical alignments track celestial cycles that remain constant regardless of technological context. The construction techniques demonstrate principles of structural engineering that could guide the rebuilding of stable architecture using locally available materials. Even the choice of locations for these monuments may reflect strategic thinking about survival in a post-catastrophe world. Many are positioned in areas that would remain habitable even during severe climate disruptions. They are often located near reliable water sources and in regions protected from extreme weather. The massive stone platforms that support them could serve as foundations for post-disaster communities, while their acoustic properties could enable communication across distances when electronic systems have failed. The builders of these structures seem to have understood that preserving knowledge requires more than just information storage. It demands the creation of systems that can function across technological discontinuities, bridging the gap between the civilization that creates them and whatever societies emerge from the aftermath of cosmic catastrophe. Their monuments were designed not just to survive stellar violence, but to remain useful and comprehensible to people who might have lost access to the accumulated learning of previous generations. Modern efforts to prepare for similar challenges must learn from both the successes and limitations of these ancient preservation strategies. We possess information storage technologies that can preserve vastly more data in much smaller spaces than stone monuments, but we must ensure that the systems we create remain accessible even when the electronic infrastructure that supports them has been destroyed. We can distribute archives globally to minimize the risk of total loss, but we must also maintain human communities capable of interpreting and utilizing preserved information. The task becomes more complex when we consider the sheer volume of knowledge that modern civilization has accumulated. The ancient builders could encode essential principles in geometric relationships and astronomical alignments, but our scientific understanding encompasses millions of specific facts and techniques that resist such compact representation. Selecting what deserves preservation requires difficult judgments about what knowledge is truly essential for civilizational recovery and what represents mere elaboration of fundamental principles. Some information clearly merits the highest level of protection. The basic principles of mathematics, physics, and chemistry that describe natural laws would remain valid even after technological collapse. Agricultural techniques adapted to local conditions could mean the difference between survival and starvation for post-disaster communities. Medical knowledge that could be applied using simple tools and locally available materials could save countless lives in a world without modern healthcare systems. But beyond these practical considerations lies a more subtle challenge. How do we preserve the cultural knowledge that makes human societies worth rebuilding? The literature, art, music, and philosophical traditions that give life meaning beyond mere survival require different preservation strategies than technical information. They depend on living, maintain, and transmit cultural communities that actively practices across generations. The ancient builders seem to have understood this distinction and developed preservation strategies that operated on multiple levels simultaneously. Their monuments encode practical information in mathematical relationships while also embodying aesthetic principles that speak to fundamental aspects of human consciousness. The same geometric ratios that describe efficient structural engineering also appear in musical harmony and natural growth patterns, connecting technical knowledge to deeper truths about the nature of reality. This integration of practical and transcendent knowledge represents a sophistication that modern preservation efforts often overlook. We focus on saving data and maintaining infrastructure, but we give less attention to preserving the values and motivations that inspire people to use knowledge constructively. A civilization that recovers technical capabilities without the wisdom to apply them responsibly might create even greater disasters than the cosmic events that destroyed their predecessors. The challenge becomes more urgent as multiple indicators suggest that the cosmic cycle may be approaching another critical transition. Solar activity monitors report increasing frequency and intensity of magnetic storms. Earth's magnetic field continues to weaken at an accelerating rate. The space weather conditions that once seemed like minor inconveniences are beginning to affect critical infrastructure in ways that preview what could happen during a major solar event. Commercial airlines already reroute polar flights during periods of high solar activity to protect passengers and crew from radiation exposure. Satellite operators routinely put spacecraft into safe mode when solar storms threaten electronic systems. Power grid managers monitor space weather forecasts as carefully as terrestrial weather patterns, knowing that geomagnetic disturbances can trigger blackouts across entire regions. These precautionary measures work adequately for the relatively mild solar events we currently experience, but they would be entirely inadequate for the kind of superflare that other sun-like stars produce regularly. The radiation levels and electromagnetic effects of such an event would overwhelm all existing protective systems simultaneously. The carefully planned emergency responses that handle routine disasters would collapse along with the communication and coordination systems they depend upon. In such circumstances, the scattered survivors would find themselves in situations remarkably similar to those faced by the builders of ancient monuments. Cut off from centralized authority and technological support, small communities would need to rediscover the basic skills of survival while somehow maintaining enough accumulated knowledge to eventually rebuild more complex societies. The information preserved in durable formats could provide crucial guidance for this reconstruction effort, but only if it had been carefully selected and encoded with future users in mind. The window for implementing such preservation strategies may be narrowing rapidly. The infrastructure required for hardened information storage and the cultural changes needed to maintain essential skills both require significant time to develop properly. If the current indicators of solar instability continue to accelerate, we may have only decades rather than centuries to complete the kind of comprehensive preparation that could ensure civilizational continuity through cosmic catastrophe. The choice facing our generation mirrors the one encountered by every advanced society that has reached this threshold. We can continue building increasingly complex and interdependent systems that maximize efficiency while creating vulnerabilities to cosmic disruption. Or we can invest in preservation and resilient strategies that prioritize long-term survival over short-term convenience. We can trust that technological solutions will somehow emerge to protect us from stellar violence. Or we can accept the cyclical nature of cosmic events and prepare accordingly. The stakes extend beyond our own survival to encompass everything that human consciousness has achieved during its brief moment under the stars. The accumulated wisdom of millennia, the artistic and literary treasures that capture the highest aspirations of our species, the scientific understanding that could serve as the foundation for even greater achievements in the future. All of this hangs in the balance between cosmic forces that operate on timescales far longer than human lifespans, and the decisions we make in the precious time remaining before those forces assert themselves once again. The ancient monuments continue their silent vigil, their mathematical messages still largely unread, by a civilization too busy with immediate concerns to study the warnings they contain. The sun gathers energy for its next great release, following patterns established long before Earth itself existed. And somewhere in the space between human wisdom and cosmic violence, the future of everything we hold dear awaits the outcome of choices we may not even realize we are making. The patterns emerging from multiple monitoring stations paint an increasingly coherent picture of approaching transformation. Deep space telescopes trained on distant stars have recorded superflare events that release energy equivalent to 1 billion hydrogen bombs exploding every second for days at a time. These stellar outbursts, once considered impossibly rare, now appear to follow predictable cycles tied to magnetic field dynamics that operate across cosmic timescales. Our own sun, despite its deceptively stable appearance, shows all the preliminary signs of entering a similar phase of magnetic instability. The mathematics of stellar evolution reveal that such events are not random catastrophes, but inevitable consequences of how stars like our sun manage the enormous energies contained within their cores. As hydrogen fuel burns and magnetic fields strengthen over thousands of years, internal pressures build toward configurations that can only be resolved through massive energy release. The same nuclear processes that sustain life on Earth also create the conditions for its periodic destruction. A cosmic paradox that has shaped the history of every world orbiting every sun-like star in the galaxy. Recent discoveries in helioseismology, the study of sound waves traveling through the sun's interior, have revealed unprecedented details about the magnetic structures building beneath the solar surface. These subsurface observations show twisted magnetic field lines coiling into configurations that mirror those observed in other stars just before superflare events. The energy stored in these magnetic structures has been accumulating for centuries, possibly millennia, creating a reservoir of potential destruction that dwarfs anything in human experience. Computer models incorporating this new data suggest that when these magnetic structures finally reach their breaking point, the resulting energy release will propagate outward through the solar system at nearly the speed of light. The initial burst of X-rays and gamma radiation will arrive at Earth in approximately 8 minutes, followed by waves of charged particles traveling at significant fractions of light speed. The electromagnetic pulse accompanying this cosmic assault will be millions of times more powerful than any nuclear weapon ever detonated, capable of inducing electrical currents strong enough to melt metal conductors and ignite fires across entire continents. The evidence stretches before us like fragments of a shattered mirror, each piece reflecting the same terrifying truth from a different angle. The isotope spikes buried in ancient ice, the sudden collapse of civilizations at the peak of their power, the mathematical warnings encoded in monuments built by hands that had witnessed fire falling from heaven, all point toward the same inescapable conclusion. We are not the first advanced civilization to face this cosmic test, and we will not be the last. Yet in that recognition lies both our greatest fear and our deepest hope. For if humanity has endured such trials before, if knowledge has survived the complete destruction of the technological foundations that supported it, then survival remains possible. The monuments stand as proof that even in our darkest hour, human wisdom can transcend the violence of the stars. The question is whether we possess the courage to listen to their warnings and the wisdom to prepare for what they knew would come again. The sun continues its ancient rhythm, gathering strength for the next great release, while we stand at the threshold between preparation and catastrophe, between the wisdom of ages and the fury of cosmic fire.